Okay, Algebra 2, we are section 1.4, solving linear systems. And we went over solving linear systems for 2 variables. So we're going to jump right away with an example here, and we're going to work with 3 variables. And with 3 variables, you need 3 equations. So 4x plus 2y plus 3z is equal to 12. That's equation 1. 2x minus 3y plus 5z equals negative 7. And your last equation is 6x minus y plus 4z is equal to negative 3. Okay, and as I work through this, I'm going to talk a little bit about steps. Now, the first thing that we want to talk about is your goal. So whenever you have these, you want to remember that your goal is to get to a 2-variable system. Because once you have a 2-variable system, it's easy to solve. And you've been doing that for a while. So get to a 2-variable system. So our actual steps here, step number 1, is that you're going to rewrite your equations so that you can eliminate a variable or substitute a variable. All right, I'm going to go ahead for this one. I'm going to start with elimination. And on this elimination, I'm actually going to go ahead, I'm going to try and eliminate x. So I'm going to try and get rid of our x's. All right, the first thing that I notice here is that I have a 4x and a 2x, meaning that I can multiply that second one by a negative 2 and set up my coefficients to work out. So let's go ahead, let's try it out here. Oh, I've already used pink. Let's use this green here. So we're simply just going to write our first equation, 4x plus 2y plus 3z equals 12. All right, so this is equation number 1. Then we're going to take the second equation and multiply it times negative 2. And remember multiplying everything. So negative 4x plus 6y minus 10z is equal to a positive 14. And let's go ahead, let's set this up for elimination. The x's, of course, disappear. They eliminate each other. 8y minus 7z is equal to 26. Okay, so far I have one equation with a y and a z. I need another equation with a y and a z. So what I'm going to do here is take my my third equation. I'm going to write that out as 6x minus y plus 4z equals negative 3. And if you'll notice, I have this 6 and a 2, so I need to multiply my second one by negative 3. So multiply this by negative 3 to set up that negative 6 for my leading coefficient. Negative 6x plus 9y minus 15z is equal to 21, and add them together to eliminate your x's, leaving you with 8y minus 11z is equal to 18. Okay, now I have a 2-variable system. So I have 8y minus 7z equals 26, and I have 8y minus 11z equals 18. So what I'm going to do, switch back to purple here, is that I'm simply just going to rewrite this over here. So we have 8y minus 7z is equal to 26, and then I'm going to multiply this guy by negative 1 to set up that negative 8y plus 11z is equal to negative 18. And then add them up together The y's disappear. And at this point, we get 4z is equal to 8. Now divide by 4 to solve for z, so z is equal to 2. All right, now we're going to go ahead and plug z into one of our two variable equations. So we're going to use this z value, and I'm going to actually plug it in right here to this green guy. I'm going to do my work on the bottom though. So we have 8y minus 7 times 2 is equal to 26. 8y minus 14 equals 26. Add 14 to both sides. 8y is equal to 40. Divide by 8, and y is equal to 5. Okay, so far I have z equals 2 and z equals 5. So if we go back to these steps over here, we rewrote for the elimination. Step 2, which is in purple here, is to solve your two variable system. So our two variable system here was z and y, but it could have been any of your two variable systems. And the last step before checking your work is to plug values back in to a 3 variable equation to solve for that last variable. And then of course, check your answers. Check your answers for this one. So we still need to solve for x. We're going to go back up to the top here and solve for x right here. So we have 4x plus 2. We know that y is 5 times 5 plus 3 times 2 is equal to 12. This one's pretty simple to solve. 4x plus 10 plus 6 is equal to 12. And we get 4x plus 16. Subtract 16 from both sides. 4x is equal to negative 4. Divide by 4. X is equal to a negative 1. Okay, awesome. So now that we have all of our values, I would ask you to go back and plug them into all 3 of your equations here. So remember to go back and plug them in, plug them in, plug them in. Make sure that you get all true statements. For essence of time on this video, I'm going to tell you that these are correct. So you need to write it in your ordered triple. So x, negative 1, y, 5, and z is 2. And I'm going to box my final answer. And just like that, we solved a 3 variable system. All right, please, please, please be methodical about these. They have a tendency to trip some people up. If you miss a negative and you go back, you got to do all the stuff involved with it. So I've got one more example for you. I'll actually scroll down a little bit. Here we go. Example 2. And I can show you that we can actually solve by substitution too. So x minus 2y plus z is equal to negative 4. And negative 4x plus y minus 2z is equal to 1. And our last equation is 2x plus 2y minus z equals 10. Okay, so for this one, we are solving by substitution, meaning that we need to isolate a variable first. I'm going to isolate x in this top equation because my leading coefficient's 1. You, of course, could isolate z too. That'd be a good option. I'm going to subtract 2y and minus z. Add 2y and minus z from both sides. So x is equal to 2y minus z minus 4. Isolating that x. Now I'm going to take this, switch to a green. I'm going to take this equation and substitute it into the x's into these second 2 equations. So that's going to leave us with, I'm going to draw an arrow here, negative 4 times 2y minus z minus 4 plus y minus 2z is equal to 1. Let's simplify some things. Negative 8y plus 4z plus 16 plus y minus 2z equals to 1. When you subtract 16 from both sides and combine your like terms, you get negative 7y plus 2z is equal to negative 15. Okay, now remember your goal is to get to a 2-variable system. I have one equation with a y and a z. I need my other equation with a y and a z, so we're going to substitute again. So 2 times 2y minus z minus 4 plus 2y minus z equals 10. We're going to go ahead, we're going to distribute 4y minus 2z, my pen is going crazy, minus 8 plus 2y minus z equals 10. You are going to add 8 to both sides and combine your like terms. For 6y minus 3z is equal to 18. Okay, here we go. We have these two equations. I'm actually going to go ahead. I'm going to stick with my substitution method, even though we're getting a little crazy with our colors, so I'm going to switch up a little bit. And on this substitution, I'm actually going to I see that all these numbers are divisible by 3, so I can easily isolate z here. So we get negative 3z is equal to negative 6y plus 18 divided by negative 3 on all of our terms, leaving you with z is equal to 2y minus 6. All right, now we got lots of substitution going on here. We're going to substitute this 2y minus 6 into this equation up here for z. So let's jump back with a pencil here. We're going to bring it all the way down here at the bottom. Negative 7y plus 2 times 2y minus 6 equals negative 15. We have negative 7y plus 4y minus 12 when you distribute. Combine your like terms and add 12 to both sides, giving you negative 3y is equal to negative 3. Divide by negative 3, and y is equal to 1. Oh boy, we're still substituting. We have one value so far. I'm going to switch back to yellow to highlight our value here. So there's one value. I'm going to use that value up here with z is equal to 2 times 1 minus 6. Z is equal to 2 minus 6. Z is equal to negative 4. There's our second value. And the very last one that we're going to do, I like to use the equations that are isolated. So I'm going to go all the way back up to the top. And we have x is equal to 2. We know what y is. That's 1. Minus z is negative 4. Minus 4 again. X is equal to 2 plus 4 minus 4. X is equal to 2. Voila, our very last value. And again, for essence of time, you of course would plug this into your calculator and check, but we're going to write our ordered triple as 2, 1, negative 4, and go ahead and box it. Oh, goodness, lots and lots of steps with them. I just have a very last example for you. Let's pick purple on this one. Very last example, one more to show you, example 3. There's some special circumstances. So x plus y minus z equals negative 1. 4x plus 4y minus 4z equals negative 2. 3x plus 2y plus z equals 0. All right, I see that we can easily eliminate z from the first one and your third one, because they both have opposite coefficients. X plus y minus z equals negative 1. 3x plus 2y plus z equals 0. Let's add these equations up together. 4x plus 3y, the z's are eliminated, equals -1. Okay, that one was pretty simple. I'm going to use the second and third equation to eliminate z again. So 4x plus 4y minus 4z, and then I'm going to take this guy over here and multiply it by a positive 4 to get the leading coefficients to match, not leading coefficients, but your z coefficients to match up. Excuse me, not 3. I'm talking and trying to. Right, so 12x plus 8y plus 4z equals 0, and I didn't say the equals on this one, this is -2. So that when you add them up, you get 16x plus 12y, the z's are eliminated, is equal to -2. Okay, we have our 2-variable system here. I'm going to go ahead, I'm going to multiply this guy by a -4 to get the x's having the same leading coefficients of 16x minus 12y equals a positive 4, and then we have 16x plus 12y equals -2, and you might see it already is that both of these eliminate, giving you 0 equals 2. Uh-oh, that's a false statement. And when you get a false statement, you want to go ahead and state no solution for this. There's no solution that would work for all 3 of these. My very last words of wisdom, I know this is a long video, my very last words of wisdom are to check your solutions. Take the time, check your solutions, because there are times where you go through everything and you do everything perfectly and it doesn't work for all 3 of your equations. Very nice job. I will see you soon.